When testing a claim about a proportion P, we need a few criteria as well. The criteria are the sample observations, are simple random sample, and they have to come from a target population. Again, pretty standard. The conditions for a binomial distribution are satisfied. Well, that simply means that we have two mutually exclusive things, one being noted as a success and the other being noted as a failure. We also need to know that n is sufficiently large, so our n times p and n times q both have to be 15. And we know that the mean of the binomial is n times p, and the standard deviation is the square root of n times p times q. This notation here, p is the assumed proportion, not the sample proportion. Remember, the sample proportion is denoted by p hat. Alright, the three different types of tests are the typical three. We have a two-tailed test. We're testing to see if the proportion equals some value versus not equaling. Left-tailed is when we're looking to see if the proportion is less than a given value, and the right-tailed we're looking to determine if the proportion is larger than a given value. P sub 0 is the assumed value of the population proportion, so this is what we expect it to be. Now in my test statistic here I just use the letter P as opposed to P with a sub 0, but hopefully you can get the idea. So the test statistic is the mean, or the value, p hat, minus the mean, which is p. We expect p hat to be p. And if you recall, the standard deviation of p hat is the square root of p times 1 minus p, or q, over n. Now here's an example. So in 1997, we had 46% of Americans say that they did not trust the media. 10 years later, in 2007, they polled 1,010 adults nationwide, and 525 of them stated that they did not trust the media. So we want to do a test for this. It says at the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? So there's our key word, increased. So we're looking to see if it's gone up or is greater than it was. Alright, so here's the pertinent information. The value of x is 525, n is 1010. So our p hat is going to be 525 divided by 1010. Our null is that the proportion equals 0.46, and the alternative is that it's increased or is greater than 0.46. Our significance level, which is alpha, is 0.05. Now, first, where I got this 0.52, typically when we're dealing with a proportion like this, we want to go 3 decimal places or 3 sig figs. So 525 divided by 1010 comes out to be 0.5198. Rounding it to 3 would be 0.520, so that's what I've used, 0.52. Now the calculation of the test statistic comes out to 3.83 after we've done the math here. Now, we need a critical value. Well, we have one-tailed test to the right, so we're looking for a positive critical value. Certainly it's going to be over in this area. Alpha is 0.05, so I'm going to do the inverse norm of 0.05 to find z of alpha. So that comes out to negative 1.645. However, we want the positive value, 1.645, because it is right-tailed. So it's going to be in this area here. Let me just draw my line. Thereabout is the critical value. So our critical region is over here. So this is the area where we reject. This is our rejection region. So any value above 1.645 will cause us to reject the null hypothesis. Well, this value here we look at it, 3.83, it's going to be well into the rejection region. So it's greater than 1.645, so we reject.